I'd like to look at series and parallel circuits, and we'll start with series circuit in a conceptual form and how it relates to amperage, resistance, voltage, and whatnot. And here we have a common circuit that we've seen in the work booklets, and we're going to give 4 ohm resistance and 6 ohm resistance to the resistors. Now if we do our little pictorial of that resistance, we can see how the charges will be restricted and then fed through the first resistor only to be restricted again. And that's important because that's the nature of a series circuit. The 4 ohm being a little bit wider, you can see the circle I've drawn above the 4 ohm, and the 6 ohm being a little bit smaller. So if we look at the math here, and it's very straightforward math of a series circuit and finding out what resistance is, it's RT, all whole numbers, and it's just a matter of adding them up. But with that now we can discover the other values. We know the voltage is 12, now we know the voltage is, or the resistance is 10. But what's the amperage? And we use a simple Ohm's law and calculate the amperage to be 10 into 12, which is 1.2 amps. Flip over to parallel circuits. It's really not that much different if you visualize the charges. So we'll draw one of our stock parallel circuits in schematic form and put 3 resistors in it. So that's 3 paths that those charges can travel in. And we'll give a value of 8 ohms for the top one, 8 ohms for the middle one, and 4 ohms, which is a little wider, for the bottom. Now again, we're going to, in more expanded way, is visualize the actual restriction in the circuit. And both 8 ohms should represent about the same restriction. And I'm going to carry this a little bit further in a minute here. 4 ohms is going to be wider. Let's bring them out so we can see what happens when they all meet again. And as if it's pipes, and we've got a complete circuit, and the first 8 ohms is going to let X amount of red, we'll call them red charges, and then blue charges, which will be the same amount. But the green is going to be it's going to be more, not much more, but more. And they're going to all meet and add up together at the end. Now the purpose of me giving them colors and whatnot is to show that each individual resistor has an amount of charges going through it, but the whole circuit, which is represented to the right, has them all the charges end up going through it. And so it would be the amperage through the 8 ohm, 2 8 ohms, and the 4 ohm added up all together. So if we added another resistor, there would be even more charges. So that's the flip of the concept between parallel and series. If we put more resistors in series, we lessen. But we put more resistors in parallel, we increase, because we increase these paths. And that's the concept I want everybody to understand. Now, you can see them all gathering together at the bottom. So that's leaving the circuit. So if we looked at, coming out of the battery, it should be exactly the same. So I'll just draw that in. So we'll go over to the battery and draw another. Well, there's no restriction there, so we're just drawing all the charges, trying to represent what's at the bottom on the right. And they're all going in, finding their various paths, and then coming out again. So that's the nature of a parallel resistor. And each resistor is another path and allowing the circuit to conduct more current. Well, a flip is just the same as a inverse in a way. But remember, when you're thinking of parallel circuits, the relationship is inverse to that of a series. So more resistance in series, less current flow, more resistances in parallel, more current flow. And that's important to remember. So the math becomes an inverse math problem. But the bottom part, all the r's are the same. It was just to inverse it, you put 1 over it. And there it is. We work with the formula that we found in our booklets and whatnot and inverse it. And we now know what the resistance is. And the resistance is 2. And if you struggle a bit with the math, there it is. It is not that complicated. And pause it here or whatever you have to do, and you can see that you inverse it's an inverse formula, and then to get the answer you want, to get R equaling, which you have to do, you just inverse it, and we ended up with, of course, the 2 ohms. And that gives us 12 volts and 2 ohms. So if that's the case, we can work out the amperage. And the amperage is going to be volts over the resistance, which is 2. And very easy to work this out, Ohm's law, and you should be used to Ohm's law. The voltage, which is 12, divide it by the calculated resistance, and that gives us 6 amps in that circuit. So we've now calculated what those resistors would do as far as amperage. Thank you very much.